What if I told you that the most advanced branch of modern science, the physics of atoms, particles, and the quantum world, has been slowly, quietly, reluctantly arriving at a conclusion that monks, mystics, and ancient philosophers declared thousands of years ago? Not metaphorically, not as a loose analogy, structurally, mathematically, experimentally, that at the deepest level of reality, there is no separation, that you, sitting wherever you are right now, are not an isolated object moving through an empty universe. You are, according to the equations, entangled, connected, part of something that has no edges. Today, we are going to explore one of the most profound and controversial intersections in all of human thought, the place where quantum physics and mysticism meet. And I want to be very clear from the start. This is not a video that cherry-picks science to validate spirituality. And it's not a video that dismisses ancient wisdom as primitive superstition. This is a genuine, rigorous, honest examination of what both traditions actually say, and the places where, against all expectation, they point in the same direction. By the end of this, you may never see reality, or yourself, the same way again. Let's begin. First, let's make sure we're on solid ground. What does quantum physics actually claim? Quantum physics, also called quantum mechanics, is the branch of physics that describes how matter and energy behave at the smallest scales, atoms, electrons, photons, and subatomic particles. And here's what makes it so strange. At this scale, the rules of ordinary reality break down completely. Consider the famous Double Slit Experiment. You fire particles, let's say electrons, through a barrier with two slits. Logically, you'd expect them to land in two neat bands on the screen behind it, like bullets through two holes. But they don't. They create an interference pattern, like waves. As if each electron went through both slits simultaneously. As if it existed as a wave of possibilities, not a definite object. Now here's where it gets deeply strange. When scientists set up a detector, to simply observe which slit the electron goes through, the interference pattern disappears. The electron suddenly behaves like a particle again. The act of observation changes the outcome. Read that again. The act of observation changes the outcome. Now, mainstream physicists will be quick to clarify, this doesn't mean human consciousness is collapsing reality with our thoughts in some mystical sense. The observation in quantum mechanics refers to any physical interaction, any measurement. But the philosophical implications refuse to stay quiet. Because what this tells us is that at the foundational level of reality, particles do not have definite properties until they are measured. Until then, they exist in what's called a superposition, a smear of all possible states at once. The universe, at its base layer, is not made of things. It's made of possibilities. And this is just the beginning. Because quantum mechanics gives us something even stranger. Something that Einstein himself called, and I'm quoting him directly here, spooky action at a distance. Quantum entanglement. Imagine two particles, two photons, for example, are created together, in the same event. They interact, become correlated, and then fly off in opposite directions. Now separate them. Put one in a laboratory in Geneva. Send the other one across the galaxy, if you like. Measure one of them. Observe its spin, let's say it comes out up. The instant you make that measurement, the other particle, no matter how far away it is, will show the opposite state. Down. Every time. Not because of some signal sent between them. Not because they secretly agreed in advance. Physicists have ruled out both of those explanations through decades of increasingly sophisticated experiments. The most famous were the Bell test experiments, based on mathematician John Bell's 1964 theorem. And in 1982, Alain Aspect and his team in Paris performed the definitive experiment. The results were unambiguous. The particles are genuinely correlated across space, faster than any signal could possibly travel. In fact, the connection appears to be instantaneous, non-local, outside of space and time as we know them. In 2022, Alain Aspect, John Clauser, and Anton Zeilinger won the Nobel Prize in Physics for this work. This is not fringe science. This is the most decorated, verified result in modern physics. So what does it mean? It means the universe is fundamentally non-local. The appearance of separate, isolated objects, you, me, this planet, distant stars, may be exactly that, an appearance. A feature of the macro world we inhabit, not a feature of underlying reality. At the quantum level, things that have interacted remain correlated, entangled, regardless of distance. Separation, in the deepest physical sense, may be an illusion. Now I want you to hold that thought. Just hold it, because in a moment, we're going to sit it right next to something written approximately 3,000 years ago. But before we do, there's one more quantum concept we need to visit. David Bohm was a physicist at Princeton, later at London's Birkbeck College. One of the most brilliant and unconventional minds in 20th century science. After years of studying quantum mechanics, Bohm proposed something radical, that the universe has two orders. The explicate order, the world we see, objects, particles, events, things that seem separate and distinct, and the implicate order, an underlying, undivided wholeness from which the explicate world unfolds, like ripples on the surface of a much deeper ocean. In Bohm's view, particles are not separate things that sometimes become entangled. They are expressions of a deeper, undivided reality that only appears separate in our perception. He called this universe a hollow movement. Each part contains information about the whole, like a hologram. Bohm wrote, and I'm paraphrasing, the notion that all these fragments are separately existent is evidently an illusion, and this illusion cannot do other than lead to endless conflict and confusion. He wasn't writing as a mystic. He was writing as a physicist. But when mystics heard his words, many of them said, yes, we know. We've been saying this for millennia. There is a problem in science so difficult that philosophers gave it a special name, the hard problem of consciousness. The term was coined by philosopher David Chalmers in 1995. Here's the problem: we can explain, in principle, how the brain processes information. We can map neurons, trace electrical signals, understand how sensory data becomes computation. That's the easy problems of consciousness, not easy, but tractable. The hard problem is different. Why does any of that processing feel like something? Why, when light hits your retina and your brain processes the wavelength we call red, why do you experience the redness of red? Why is there an inner experience at all, rather than just silent biological machinery? Science doesn't have an answer. And the reason it doesn't have an answer is that consciousness sits outside the normal scientific framework. It's subjective. It can't be measured from the outside. It can't be put in a test tube. Materialism, the standard scientific worldview, says consciousness is produced by the brain. It's an emergent property of complex matter. But here's the tension. If quantum physics tells us that observation affects reality at the fundamental level, what is an observer? Some physicists, including the brilliant John von Neumann, who helped formalize quantum mechanics mathematically, argued that ultimately, consciousness itself is what collapses the quantum wave function. Not detectors, not machines, awareness. This is a minority view in physics, to be clear. Most physicists find ways around it. But it hasn't gone away, and certain interpretations of quantum mechanics, like the many worlds interpretation, the Copenhagen interpretation, and especially the lesser-known von Neumann-Wigner interpretation, each handle consciousness differently. What's striking is this: mainstream neuroscience says the brain produces consciousness, and yet mainstream physics cannot define what an observer is without running into consciousness. These two fields, at their edges, are circling the same mystery, and at the center of that mystery sits a question mystics never stopped asking. What is awareness? What is the observer? Is consciousness something the universe does, or something the universe is? Let's now do something rarely done honestly: place what ancient traditions actually claimed next to what modern physics actually found, and compare them with integrity. Ancient Vedanta, Hindu philosophy, dating back over 3,000 years, teaches that the universe is ultimately Brahman, a single, undivided, conscious field of being. Individual selves, what they call Atman, are not separate from this field. They are expressions of it. The appearance of separation is called Maya, illusion. Quantum physics, particles are non-locally entangled across space. David Bohm's implicate order proposes an undivided wholeness underlying apparent separateness. These are not the same statement, but the structural logic, undivided wholeness beneath the appearance of separation, is strikingly parallel. Buddhist philosophy, particularly in the Madhyamaka tradition founded by Nagarjuna in the 2nd century, teaches that phenomena do not have inherent, independent existence. They arise in relationship, dependently. Nothing exists from its own side. Quantum physics, particles do not have definite properties independent of measurement. Properties are relational, not absolute. The act of measurement is part of the phenomenon. Again, not identical, but the core philosophical move is the same. Reality is relational, not absolute. Things don't simply exist, out there, fully formed, waiting to be found. Indigenous traditions across the world, from the Lakota concept of Mitikyoya Zayang, all are related, to the African philosophy of Ubuntu, I am because we are, insist that identity is not individual but relational. You exist through your connections, not in spite of them. Quantum entanglement, once particles interact, they remain correlated indefinitely. In a very real sense, everything that has ever interacted with anything else carries a trace of that connection. Given that all matter in the observable universe emerged from the same initial conditions at the Big Bang, the same quantum event, everything may, in a profound sense, be entangled with everything else. Now I need to pause here and be honest with you, because intellectual honesty matters. The parallels are real, and they are remarkable, but they are not proof that ancient mystics had access to quantum physics, or that quantum physics validates spiritual experience. Here's why that matters. Quantum effects operate at scales incomprehensibly smaller than anything we perceive in daily life. Quantum entanglement doesn't mean you're telepathically connected to your friend across town. The math does not work that way, and ancient wisdom traditions, however profound, were not doing controlled experiments with particle accelerators. Their insights came from different methodologies: contemplation, experience, philosophical reasoning, not empirical measurement. What we can honestly say is this: both traditions, approaching reality from completely different directions, arrived at a similar intuition, that what appears separate is, at some deeper level, unified. That is significant. It doesn't prove either one, but it raises a question worth sitting with. There is a place at the edge of quantum physics where the equations give out, not because they're wrong, because they bump into questions that math can't answer. Questions like, why is there something rather than nothing? Why do the laws of physics have the specific values they do, the constants that make atoms, stars, and life possible? What exists before the Big Bang, before space and time as we know them? What is the relationship between the physical universe and subjective experience? These are not idle philosophical questions. They are unsolved. Actively unsolved, among the brightest minds on Earth. And here is where I think the conversation between science and mysticism becomes most valuable. Not because mystics have the answers physicists need, but because both traditions, at their best, are trying to do the same thing: understand what is real. Science proceeds by measurement, prediction, falsification. It excels at the how of reality. Contemplative and mystical traditions proceed by direct investigation of experience, not of the external world, but of awareness itself. They ask not, how does the universe work, but, what is it to know? What would it mean to bring these two together, seriously and rigorously? Some scientists have tried. Physicist turned philosopher David Chalmers, neuroscientist turned contemplative Francisco Varela, who worked with the Dalai Lama for decades. Physicist Carlo Rovelli, whose relational interpretation of quantum mechanics reads, at times, almost like philosophy of mind. Mathematician Roger Penrose and anesthesiologist Stuart Hameroff proposed, controversially, that quantum processes in microtubules inside neurons might be the physical basis of consciousness. Most physicists find this unlikely, but the fact that serious people are asking it tells you something about the depth of the mystery. We live in a moment when science is confronting questions it cannot answer within its current framework, and wisdom traditions, long dismissed as pre-scientific superstition, are being re-examined with new respect. The conversation is beginning, and it may be the most important conversation of our time. I want to end not with physics or philosophy, but with you. Because whether or not quantum entanglement is literally the mechanism behind human connection, and the physics suggests it probably isn't, at our scale, there is something these ideas can do for the way we live. If you take seriously the possibility that separation is, at some level, a construction, that the boundaries between you and the world are not as absolute as they feel, what changes? Maybe the harshness with which you judge others softens slightly, knowing they are, at the most fundamental level, not entirely separate from you. Maybe the loneliness that so many of us carry, that deep sense of being an isolated self in a vast, indifferent universe, becomes a little less convincing. Maybe the impulse to consume, to take, to hoard, built on the assumption that what I take from the world doesn't come back to me, starts to lose some of its grip. The mystics didn't arrive at, "we are all connected," as a nice feeling to have. They arrived at it as a description of reality, something they experienced directly in states of deep contemplation. The physicists didn't arrive at non-locality as a spiritual teaching. They arrived at it kicking and screaming, because the experiments demanded it. And yet, here they are, standing at the same place. Physicist Richard Feynman once said, "I think I can safely say that nobody understands quantum mechanics." And the mystic Rumi wrote, "Out beyond ideas of wrongdoing and right doing, there is a field. I'll meet you there." Maybe that field, the one the physicist can't fully explain and the mystic can't fully describe, is the same field. Maybe reality is trying to tell us something, and maybe the most honest, courageous, and important thing we can do is stay in the question, not rush to an answer, not collapse the wave function before we have to. If this video stirred something in you, if it raised more questions than it answered, good, that's exactly what it was meant to do. Drop your biggest question in the comments. I read every single one. If you want to go deeper, I've linked the key books and papers in the description below. This rabbit hole has no bottom, and it is glorious. Like the video if it moved your thinking. Subscribe if you want to keep asking these questions together. And until next time, stay curious, stay open, and remember, you are not as separate as you think.